So the word recursion, if we look into it, we can see that there's this word recur. And recur just basically means that there is reoccurrence. And reoccurrence just means that something occurs again and again and again. So recursion in computer science is just a concept agreed upon by a lot of people, or should we say a concept agreed by scientists. It's just a concept that describes a certain block of code, but let's say not necessarily a block of code, but let's say it describes a certain instruction or instructions. It describes a particular instruction that calls itself again and again. So let's say we have a instruction and we encapsulate this instruction in a box, and the instruction is just write one. And what happens first is that when it runs first, it's write one and then we call it, and it writes one again and then we call it again, and it writes one again. And so we keep calling it. It keeps writing one, and then we keep on doing this, and it only stops until it reaches a certain base case. So that's basically the gist of recursion. It's just when a function calls itself again and again, but in our example, we manually called it. But in literal code, the function calls itself again and again until it reaches a base case. So to further understand recursion, let's go for some examples. Let's say you were invited in a dinner party. And let's say for our example's sake, this dinner party only serves peas. So let's say here's your plate, and let's say what the waiter gives you is around, let's say 15 peas. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 peas in total. So the plate you have is 15 peas. Let's say for the sake of this example that we label this piece. So we'll label this P 15th, and then this one 14th, and then this one 13th, and 12th, and then 11, and so on. Let's say for a particular reason, you really dislike peas. So it's a good thing that you brought yourself a emergency pea eating robot. And let's say this pea eating robot is connected to a button. And this button right here, when pushed or clicked, commands the robot to eat the specified pea or the specified nth pea. And let's add an additional function, which is n minus 1. So let's talk about n minus 1 later, and let's just say that n in our example here is 15. It's the number of peas. So let's go back to our situation here. So you realize you're just gonna eat peas for the whole night because the restaurant's just gonna serve you peas for the whole night. So you decided you're just gonna leave. But before you leave, you should eat all the peas so that you won't have leftovers. So what you're gonna do here is you're just gonna command your robot to eat the peas so you won't have leftovers. So you're gonna command your robot and then you're gonna press the button, eat the nth pea. So it will eat a specified pea. So in our situation, nth here is 15. So it will eat the 15th pea when you press the button. So the robot will take the command and then eat the 15th pea. And remember earlier we added a command to the button n minus 1. So all it's just gonna do is it's gonna subtract n by 1. So n becomes 14. And then when you click the button again or push the button again, the command will be sent to the robot. It will eat the 14th P, and the 14th P will be eaten, and then it will go again to n minus 1. It will just subtract n by 1 and it becomes 13. And then you press the button again, and then the robot's just gonna eat the 13th P, and then n minus 1 is gonna happen again, and it will just subtract n by 1, and then n becomes 12. And then you press the button again so that it could eat more peas, and it will eat the 12th pea. The robot will eat the 12th pea, and then it goes back again, and n minus 1, it will subtract n by 1, and just becomes 11, and then press the button again, and then n becomes 11, and then the robot just gonna eat the 11th p. Then it will subtract 11 by 1, and then let's say you keep on doing this until you are only left with a single p, or you're only left with the first p. So you keep on doing this, and the robot keeps eating the p. You keep pressing the button, the robot keeps on eating the p until you are only left with a single p. So now we're left with a single p. So we're gonna press the button, and then the robot's gonna eat the 1th p, or the first p, and then it will subtract n by 1, so n just becomes 0. So now in this case, we have n equals 0. So let's say you still keep on pressing this even if n equals to 0. So it will command the robot to eat the 0th p, but the robot doesn't know where's the 0th p since there's no 0th p in our plate. So this case is a perfect example, sometimes in formal code, where sometimes the code reaches an error, or sometimes it will run infinitely because the computer doesn't know what to do when this certain case appears, when the objective is already done but the function or the command keeps on running, or in our case when n equals to 0 and there's no 0th p. So to prevent this from happening, we're gonna add an additional command to the button, an additional condition where if n is equal to 0, we're gonna stop, or we're not gonna do anything. And in formal code, we sometimes write the word break, exit, or return in order for the function to stop. And earlier we mentioned about the word base case. Basically, this condition where n is equals to 0 is the base case, where the function stops, or the function stops doing anything, in order to prevent an error or an infinite recursion. So basically, that's just how recursion works in computer science. Something occurs again and again. But in our previous example, we manually press the button, or we manually call the button. But in formal code, or in literal programming code, the 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 button itself will have a command where it will press itself, or it will call itself, so that one press will automatically create a recursion, so that we don't have to manually press it again and again. One press will be enough. We're just gonna add an additional base case wherein if the objective is completed, we're just gonna stop the recursion. And that's just the base case. So ultimately, recursion is just something when a function calls itself again and again. And to end this video, if you search recursion in Google, you would encounter a recursion.